In this video, we'll continue with learning about the data transformation tools in R. Remember, in the last video, we talked about row-wise verbs, which were filter, arrange, and distinct. In this video, we'll talk about column-wise verbs, mutate, select, rename, and relocate, and talk about some of the grouping verbs. So let's get into it. So the first verb that we will talk about, which is a column-based verb, is called mutate. And as the name suggests, it allows you to add new columns based on the values that you have from existing columns in your data sets. So it's basically essentially allowing you to create new variables, or it's allowing you to mutate your original variables, but you generally want to give it a new name because you don't want to alter your original data set. Okay, but you can mutate on existing variables, replace those with whatever formula, or you can create new columns and new variables. But going and creating new columns is the way to go. So let's take a look at what we might want to create. So in our flights data set that we've been working with, we can compute the delay, which can be the total delay for a flight. And let's say we want to create not just this variable, which is the total delay for a flight, but we also want to calculate the speed in miles per hour. Because remember, in the last video, we said we have distance as well as time, okay? Air time. So let's take an example. If, let's say, a flight took off 60 minutes late, so the departure delay variable that we know, this is a departure delay. Let's say if that's 60 minutes, and then if it arrived 10 minutes early, right? So the arrival time, let's say this variable is negative, right? Then we can say that the total delay is 60 plus, so the total delay is departure delay plus arrival delay, right? So 60 minus 10 equals 50 minutes. So we could have some kind of a formula that we can put in our column-based verb here, mutate. Okay, so how are we gonna work with this? So remember, the first thing I told you when we are dealing with dplyr verbs is that we always want to supply the data set. So we begin with supplying the tibble or the data frame called flights, and then, so this is again the pipe function, which is read as and then. So we take the flights data and then we mutate. So notice here, mutate is the verb, and we open parentheses, and we can create not one, but many variables, as many as you want over here, new variables that you want, okay? So the first variable that we are creating here is called delay, and delay basically is based on something we already have, some data that we have in our data set, which is departure underscore delay, which is one column, and another, which is arrival underscore delay. So if we add this up, it kind of tells us what the total delay was, okay? And then as soon as we add a comma, we can go to the next line and we can type in another variable that we might want to create, right? So both of these will just be added as new columns in our data set. And so if we want to calculate the speed of the plane or the flight, then we can just take the distance divided by the airtime times 60, right? If we want to convert that here. So let's just take a look here. Clearly, when we do this, it doesn't show us the newly created variables. And that's why I will teach you how to, once you've done this, what can you do so that those variables actually appear somewhere where you can see them. So let's talk about dot before or period before. So use the dot before argument to instead add the variables to the left-hand side. So if you just add, after you've created the variables here, if you want to put a comma here and you want to say dot before equals 1, it's basically going to put all of those variables that you created here before the first column. Okay, so notice now we have delay and speed as the first two columns instead of year, month, and day, which were the first few columns, right? And notice also that we've gone from 19 variables to 21 variables, which is because we've added two variables to the data set, okay? Now notice it's not stored. So if you want to store this, you have to say flights, assignment operator, and then all of this code, okay? So that's how flights will get replaced, but you can call it something else if you want. You don't actually, I suggest you always create new objects and not replace your original data. Let the original data be there. Uh, and you can create different copies when you're doing different things, but not too many, so you get confused. But here is a delay and here is speed, okay? So this is sort of, if you wanted to get this in miles per hour, that's what you're doing here. You can also use the dot after if you wanted to add the newly created variables after a variable. And you don't really have to specify, the column number. You can also write something like put all of these newly created variables after the column day, right? So what it does is it doesn't alter the first three columns, but because we said let's put the newly created variables after the day column, it's going to put delay and speed over here, okay? So it's a very useful thing because it does let you see where your newly created columns are. Now you can also create the dot keep argument to control which variables are kept after a mutate operation. This is interesting because, sometimes we're not dealing with all of the variables in our data set. We don't necessarily need all of the variables in our data set. So maybe we only want to keep the newly created variables and all of the variables that were required to create those newly created variables, right? So remember that, we created delay and we created, I can't see speed, but anyway, let's just say here that we created delay, we created hours, and we created delay per hour, right? So maybe we created these three variables, and then we said dot keep equals used, right, in quotes. Then it's going to keep all of the variables, the new variables, and all of the variables that were used to create these new variables, as you can see below. So this is just, I'm heading the data here, so you only see the six. Notice I'm heading the data here, so that's why you're only seeing, by default, only 6 rows, but obviously the data is much bigger than that. Remember, you can always save the data. You can either replace the flights data or you can overwrite. So you have to basically make this decision of whether you want to overwrite your data set or you want to create a new object. So you decide that. But let's say you were interested in just having some object which was flights underscore delay, which is just manipulating this flights data and keeping all those delay variables that we created or we used. So you can then have a code like this, okay, where you're just keeping those variables that you used. So just good to know. Okay, now coming to the next verb when it comes to columns, which is select. This is absolutely useful for you when you're dealing with a data set that has many variables and many columns, and you don't have the patience to look through everything, or sometimes you don't need some things but they're still in there. Select can help you reduce the dimensions of your data. It can do many things right at the top of your, when you're trying to create a subset. So select, like the name says, allows you to select or pick which columns or variables to use. And the first column to select is a data frame, and subsequent arguments are the columns that you would be using. The order in which you list the columns in the command will determine the order in which the columns are returned by select also. So let's just take an example here. Let's say we take the flights data and then we select year, month, and day. Notice we have those columns in our output, right? So we have all of the rows and only the 3 columns that we selected. So this is a very nice, perhaps even easier way of extracting the data, okay? Let's look at another example. Another way of extracting columns could be by using the colon in between 2 column names. So if we know what our data set looks like, and let's say we know that, this probably is not really great if we only had 3 columns that we wanted to extract and we knew, but if we had many columns between year and day and we wanted to get all of those, then colon is really efficient, okay? So it's going to select all of the columns between year and day, and this is going to be inclusive of the endpoints here, or the starting column and the ending column, right? So it's going to report year as well as day and everything in between, all of the columns in between. So that's another way of using the select verb to do that. Let's take a look at, in both my examples here, the first and the second, notice that R is not giving us all of those other columns. If you did want that, then you can, I'm sorry, no. If you wanted to get rid of those 3 columns that we had, then we can use the not operator. And remember, this not operator is basically going to negate this condition here. So it's going to get rid of all of those columns and give us everything else, okay? So because our data set, if we go back here, if we go back and we try to look at what the flights data set is, here it's saying year, month, day, and then it has departure time and so on and so forth. So if we wanted to get rid of these 3 columns here, we're just saying, we're just putting a not in front of year, today, and then it's going to give us everything from departure underscore time to all of those other columns, right? And notice here the dimensions have changed. So since we've taken out 3 columns, we are left with 16 columns. Now, you are familiar with something that we've done before in data extraction, where you could take the flights data and then you can select, and you can still try to write out what you don't want with the negative in front of the vector, right? This can also work, but I suggest you always use the not operator because it works more seamlessly with Boolean operators, okay? Now, it's possible that sometimes you want to extract or look at particular types of variables that are there. So maybe you're interested in all of the logical variables in your data set or all of the numeric variables in the data set, etc. Let's say we were interested in character variables. You already know what these are because you have probably looked at the structure of the data set by using glimpse or something like that, or str, right? And you already know what these variables are, but sometimes you have too many variables and you can't really get a sense of it. So this is where this command is useful. So that command is going to be is.character, and we're going to use the var function here. So we're going to say flights, take the data frame flights, and then select those columns where where basically those variables are character, or are of the type character. So what it returns here is our 4 columns, right? All of the rows for those 4 columns where we have character variables or character vectors. So carrier, tail number, origin, and destination. So now we can see that these are also specified as characters, and that's what we get. Okay, but again, like I said, you can use is.logical, is.numeric, is.na, etc. to return what you want. Now, there are some very useful helper functions that you can use alongside select. Those are called starts with, ends with, contains, or rename. These are very useful when you have variables that are listed with a certain type of name that is intuitive, and you want to get all of those. So let's try to take a look at how we might be able to use this. So if we use starts with and we put ABC, what it's going to do is it's going to match all of the names that begin with ABC, okay, because it says starts with, right? So it's in the name that anything that starts with this, it's going to return all of those columns like that. So it's kind of doing a partial match on text data. So let's say we were interested in everything that started with DEP. Maybe I am interested in looking at departures, okay? And I take that data set that I have, flights, and then we can select, and then within select, we are using the starts._with command, and we are saying DEP. So it's going to return to us all of those variables that start with DEP, right? And that's departure underscore time and departure underscore delay. So we have two variables here that are returned, so we know how to do that, okay? Now, you can also, just like you're using starts with, you can use ends with. It is just going to match the names that end with that string that you specify, that character that you specify. So let's say I was interested in looking at everything that relates to delay. Any variable that's ending in delay, I can then take the data frame and then select everything that ends with delay, and delay is in quotes because it's a character match, okay? And again, it's returning all of those 336,000 some rows and the two columns, which is departure underscore delay and arrival underscore delay, which you already know what these mean. A partial match can also be, if you did not know whether it starts with something or ends with something, but maybe intuitively you know something contains this, then you can also use contains in the code, okay, in select. Again, it does like a partial match. So maybe if we are interested in everything related to time, okay, so we take the data and then we select everything that contains the word, or sorry, the character's time. Okay, so notice it returns 6 different columns: departure underscore time, schedule departure underscore time, and so on and so forth. Okay, so this is very interesting as well. Now, it's possible that, when you're selecting variables, you're not very happy with how those variables are named or called. So you can, while you're selecting those variables, you can use a syntax here. You can say new name equals old name and still call out those variables. So let's take a look. Let's say we took the flights data frame or table, and then we selected, and now we're using this syntax. We're saying, let's give this old name, tail number, a new name, which is tail underscore num. Okay, so this is maybe more appealing to us because it sort of separates the two words, and it's more intuitive when we are looking at it. This maybe people don't understand, but this is just an example. Okay, so what it does is that if you did this, if you said new name equals old name, it will just rename that column. And notice here, now it's put an underscore in between. So it still nothing changes in terms of the nature of the data, but you've just changed the name of the column. So that's another way in which you can There are many ways in which you can rename things, rename your columns, but this is if you were selecting those columns, you could do it in one shot. Okay, now coming to rename. Rename is another type of verb that you can apply to columns. It's in the name what you're trying to do. Okay, so what I showed you before here, where we were trying to really not use the rename verb, but we were trying to use some kind of syntax within select. It can actually do the renaming for us, but we can do it more explicitly here. So if you want to keep all of the existing variables and we just want to rename a few variables, we can use rename instead of select. Okay, so that works as well. So here we are renaming. Again, when we rename, remember this is, we're not using select here, we're using rename here. We're again using the same syntax, new name equals old name. And you know, here we don't see it, but you can always use the dot before and try to see where tail number went. Okay, so this is going to work seamlessly. Now, sometimes we don't like the order in which our variables are structured in our data, and we want to move things around. We want to maybe keep some variables that go together, you know, together, and then move some of the important variables that we might be using a lot to the front. Okay, so we can use the relocate command in order to do that. So let's take an example here. So let's say we wanted to put time underscore hour and airtime in the front. Okay, in the front means to the far left of our data frame, okay, or of our table. So notice here, when we take the flights data and then we relocate, and then we only specify those two variables, in that order, those variables are relocated to a new position, which is the first, and now it becomes the first and the second column of our data set. The number of columns remain unchanged, the number of rows remain unchanged. It's just like you're moving things around because you like time and airtime to go together. Okay. You can also use the dot before and the dot after, just like we used in mutate with relocate. So if you wanted to, if you knew where you wanted those columns to go, you can use the dot before and dot after arguments, just like you have in mutate. Okay, so let's see here. We're taking our data set and then we are relocating anything that starts with arrival. So we're, you know, combining a lot of things here. So anything that starts with ARR, which is something related to arrivals, and we are putting all of that before departure time. So you can always try to look at what happened to the data set ultimately. We can even try to look at it here. But after is going to work like that as well. So you can try to see here. We can relocate even using the colon here if we wanted to move all of these things after a particular variable. We can do that. So it's going to relocate all of these to after time underscore hour. So let's just see if that works for us. Okay, we go back, and then here, let's type this in. And notice we're using the after function here. And let's just, I'm going to put head here so that we're only looking at the 6 values. Okay. Now here it says, what did we do? We took everything from year underscore departure, year to departure underscore time, and moved it after time underscore hour. It's not showing us everything until we store it. So let's just store it as, let's call it displaced. displaced, just so that we remember what we did. Doesn't have to be that name, but you can call it anything. So if we look at displaced here, remember what we were doing here was we were moving everything from year underscore departure under year to departure underscore time to after time underscore hour. So let's go to time underscore hour. Yep. Here's time underscore hour. And then all of those columns, the four columns, the first four columns have moved, to the kind of right end of our um, and actually we should get rid of the head because we don't need the head if we are doing this. Okay, so now notice displaced is going to be, I was wondering why we had 6, but now we can see that displaced is basically a full data set, right? It should have all of the rows. We're just moving the columns around, so it should have all of those 19 variables, but it's just going to move the first few columns to the right. Okay, so in this way you can use before and after in very specific ways and just kind of reorganize your data set according to your preferences. Now, we have used the pipe function before, and the pipe function is really powerful because it allows us to combine all of the multiple verbs that we've been learning about. Okay. There is a shortcut because we're going to use pipe so much. It's good if you know this, but I'm just going to tell you how you can get that shortcut going. So let's say you're here in your script and you want to type the pipe function. If you are on a Mac, you're going to do Command Shift M, the letter M for Malaysia, and you'll see this pop up. Okay. If you're on a Windows or whatever, then you're gonna do Control Shift M, okay, and that's going to pop up. Okay, I mean, actually on a Mac also that works, so it's really up to you. If that's not coming up and this is what's coming up for you right now, here's what you can do. You can go to the tools function, okay, and let's go to global options. And when you go to global options, you can go to code and make sure that this condition here, this option here is checked, which says use native pipe operator. Requires, R to be a version 4.1 or later, right? Just make sure that this is checked and hit OK or apply. Right? For me, it's already enabled, so I don't have to do anything. But if it didn't come up for you, then it's good to have that. Maybe you're going to use the shortcut. Maybe you're just going to find it easy to type the pipe as it is. It's up to you, but I have to teach you, so I'm telling you that. Okay. Now, so one of the things to remember is the code. Whenever you're coding with the pipe function, the code is very easy to follow. So if you're working with someone, you're in a data science team, it's very easy for people to understand what you're doing because of the way it's written, right? Remember, we took flights and then we filtered by destination and then we computed the speed, right? And then we selected these columns and then we arranged speed by descending order, right? So you can read this as English, which is fantastic, right? You can understand this code. If you didn't work with pipe, what would that code look like? Super cumbersome, okay? Not super, but still you would have to wrap a lot of things. You would have to kind of go backwards. Okay, so you can try to look at this code. There are 2 examples that I've given you for what that code could look like if you were trying to do it in different steps. But I suggest that you only learn how to code with pipe, but still look at those and try to see if you can understand those. Okay, moving on to groups. How do we use group by? That's the first thing we're going to learn. Now, a lot of times you might be interested in looking at what's going on with different types of groups. Um, this could be that you're interested in particular months or years, so you can group by year. You can group by particular months because maybe you want to examine some kind of seasonality around it, or you can group by different types of unique pairs of airports and things like that. So there's a lot of ways in which we can use group, and we'll try to see some of those today. Again, like I mentioned earlier in the previous video, that when group by is combined with summarize, it turns into a really powerful tool because it does give us some summary stats about specific groups, right? So that's what we're going to learn about, okay? And then also we'll talk about the slice function. So, like I said, group by is just, going to indicate what sort of groups do you want to create if you want to group your data into specific categories, okay? So this is how you could deal with it. You can say, here's the flights data, and then group underscore by month, right? So you're telling it which column or which variable should the data be grouped by. So it's almost like R is going to put all the months into different baskets and then do some analysis on it, okay? But we're not doing any analysis just yet. We are just telling R group it, okay? And how do we know that that actually worked? Notice that earlier you only had this one line come up. Now you have R reporting to you that there are groups. There are 12 groups based on month that this data is processed as, okay? So even though your underlying data hasn't changed, you have told R that we are grouping by month, okay? But by itself, it doesn't do anything, okay? So you have to combine it with something. That's why we need summarize. So summarization is the most important grouped operation, because generally we don't want to do like one size fits all. We don't want to, let's say, we had data on salaries for men and women. So maybe we're not interested in just average salaries for the data set. We want to know what are average salaries for each group. In that case, you're going to group by, let's say, sex. And then you're going to say, um, male, female, men, women, whatever, right? And then you're gonna go ahead with that type of categorization and summarization. So what it does is when you combine group by with summarize, it reduces the data frame into a single row for each group, right? So for each group, like I said, for women, you might be computing average salaries. For men, you might be computing average salaries. And then you're just summarizing the data with a single statistic. Of course, you can have many other statistics, right? You might be wanting to report what's median salary for each group, or you might want to report the maximum salaries for each group, stuff like that. So you can have many different statistics, but again, those apply to the different groups in your data. So let's take a look at how we can compute the average departure delay by month, okay? So we can take our data set, flights, and then we can group by month. And then we can use the group by with the summarize, the very powerful summarize function. And within summarize, we're going to write down the name of the variable that we want to create, just like what you were doing in mutate. And we're going to say, what is that equal to? So we're going to say, once this is grouped by month, I would like R to calculate, or we would like R to calculate the average delay, right? This is the name of the variable, which is equal to the mean. The mean is mean because it's in blue. It's, it's calculating the function here. It's a function that's going to operate on a particular variable. So we're basically saying first you group, right? You create different groups of all the different months, and then you compute the average delay using the departure underscore delay variable, okay? And notice here our output is going to give us month and average delay. And whoops, what happened here? We have all these NA values, right? So why did that happen? Because maybe we have some values that are NA values in departure underscore delay, right? So what we can do then is just put that na.rm equals true. That means that we are removing the NA values before calculating the mean, and then R calculates it beautifully, right? So here we can see that for each month, we're gonna have, notice here, 12 rows, right? Because we have 12 months in that year. I mean, in any year. But we only have data for 2013 here. Even if we had data for many years, we could do that, right? So in this case, we just have two columns reported, which is month followed by the variable that we were creating here, delay, okay? And which is just the mean. I'm sorry, it should have been average delay here, but it didn't carry forward. That's fine. It's just delay. It just will override anything before. That's called delay. It doesn't matter. It's just a variable that you're calling. Equals mean departure underscore delay, NARM equals true. So just you have to remember that anytime you're trying to do this and you have NAs, just make sure you are putting that argument here, okay? Now you might be interested in looking at the number of rows in each group, okay? So we might want to understand, for example, let's just see what's going on here. It seems like, okay, it seems like here what we're doing is we're calculating the mean delay for each month, right? Because we are grouping by month, and then we are summarizing this. And then we are also reporting how many flights within that group had an average delay. Well, how many, so no, we're basically saying here, we're saying, let's group by month, right? And then summarize, and then calculate the mean. And then for each of those months, also report the number of flights, the total number of flights that were used to calculate that mean. So notice here, this is saying in month 1, which is January, we had 27,004 flights. In month 2, we had 24,951 flights. So in that sense, what you're doing is here you're calculating the averages because you're using the mean. And then you're also, for each of those categories or groups that you created, you're also just saying n equals n empty parentheses. And this is very powerful because it's counting how many flights went into each group, which is each month, right? So here we can see the N is reported. So clearly we can see, let's say that in June, we had more flights than in January. Or February is like a slow period, right? Because you have 24,000 flights here versus 28,000 in June. So that's what's going on here. Okay. Now we also have a bunch of slice functions, which you may or may not use depending on the need. So I'm not going to go into too much detail, but it's good to know what these do. These let you extract specific rows within each group that you can use. So sometimes you might want to take some kind of data frame and then use slice underscore head. Here, if you put n equals 1, it's going to take the first row from each group, right? So however the data is sorted, if you wanted to extract each the first row from each group, that's what slice underscore head is going to do. It's like taking a loaf of your bread and knowing, okay, this is the, beginning. I mean, loaf is not a good example here, but you have like a head or a tail somewhere, and you're basically chopping off the first row from like the first slice, right? From the left and maybe from the right. So slice underscore head and slice underscore tail does that for each of those groups. There's also slice underscore minimum and slice underscore maximum. Only when you kind of play around with this would you know how these work. But this is more, kind of going into the weeds. Sometimes you might need it, sometimes, most of the times you wouldn't. But this is basically going to give you, let's say, slice underscore minimum gives you takes the row with the smallest value of column X. Similarly, slice underscore max gives you the maximum value, largest value from column X, okay? And then, yeah, then there's also sampling, which again, we don't need to get into the weeds of it. Now, let's say we wanted to find out the most delayed flights upon arrival at each destination. Let's say we wanted to know that, okay? How could we do that? The first thing we want to do when we want to read this, when we read this prompt here, if we want to find the most delayed flights upon arrival at each destination, quickly we would know that maybe we have to group by destination, okay? So that's the first thing we're going to do. We'll take flights and we're going to say group by destination, right? And then we want to find the most delayed flights, right? So maybe those delay that departure, so this is upon arrival, so the arrival delay is going to be the maximum or the most, right? The biggest in value. So we can use the slice underscore max function here, and I'm just telling you how it works. We can apply that on arrival underscore delay, which is available in our data set, and we can say just extract the first value from it because it's the maximum value, okay? And then, I mean, this is extra over here that I wrote, but basically it's going to allow you to look at, let's just do this and see what's going on. So let's say we wanted to find out for each destination the maximum arrival delay, right? So we're writing something like this, but we're going to do this step by step. So let's just say we ran this. Let's say we ran this. And we have something like this come up in our console. So let's take a look at our console. It says, it really doesn't show us arrival delay here. So that's why I had this written before. We're going to use relocate. We're going to relocate. Okay. And maybe run this again so that we can actually see things clearly. So take a look here. Now, because we relocated destination and arrival delay, we can actually see that for each destination airport, we have arrival delay listed here, okay? But then again, this is not in order. So we can then use the pipe function and we can arrange arrival delay in descending order, maybe because we want to find out which destination airports have the maximum. So if we run this whole thing, notice we're going to have all of the flights reported, and it seems like arrival delay was in Honolulu 1272 minutes, okay, in 2013, month 1, day 9. So we know that it's 9th of January 2013 when there was this much arrival delay. And then also this was also delayed by a lot, right? So it was both. Okay, so we kind of looked at this, and then for each of these, you can see that that's what's going on, each of these destinations. But one thing to note here is that the the groups that were created based on unique destinations were 105. But what we have here is 108, right? So for each destination, we were trying to figure out which flight had the maximum delay based on arrivals, right? So you see that Honolulu should not repeat in the data. But sometimes it might be the case that you end up with more rows than groups. And that's because there are sometimes ties in the data. So if you go down very carefully and you look at your data, you might find, so you see here it's 444, but again, these are different airports, so this doesn't matter. But wherever we see a pair where the airport is the same, I'm sure we can find it. It's just I'm looking at the screen for so long, so I can't find it. Oh, I found it. Okay, so take a look here, for example. This is probably, is it Charleston? I can't remember what this airport is, CHS, but you see that CHS appears twice, right? So it's giving you, slice_max is going to look at every unique destination, and it's going to give you the maximum arrival delay time, which is 331 minutes. But in some cases, there is a tie, because for this particular destination airport, there were probably two flights that had the same arrival delay time. Notice they are on, they're obviously on different days and times. So notice this one in 2013 was month 3rd, day 8, right? So this is March 8th. And then this one was month 9, day 2. So this is 2nd September, for example. So for this airport alone, we had, 331 minutes was the maximum arrival time, but it happened twice. So R is going to throw out or spit out all of those ties also. It's not going to do any tiebreaker or anything like that. That's why you have more than 105 observations. But anyway, this is just, kind of a fine print here that you should know about. So let's go back. So how do you deal with those ties? Okay, if those, because you use slice_min or slice_max, that's going to keep the tied values so that n equals 1. It will just mean that you will get all of the rows with the highest value. If you only want one row per group, you can set with ties equals false, and then it will get rid of those. Now it's possible that sometimes you just don't want to look at 1 or 2 values for a particular destination, but you want to get like the top 10% in each group, right? So in the code, you can replace n by proportion. So proportion equals 0.1 would just mean that you're extracting 10% of all of the flights that have, so within each group, you're extracting 10% of the rows, right? So for each destination, you're extracting 10% of the rows that have maximum delays, okay? And, again, it's going to report that. Now, it's possible that you want to group by multiple variables. You can do that, okay? If you want to group by year, month, and day, and you want to get another object, you want to form another object called daily, you can do so by taking flights, pipe that, and then group by all of these, and then just take a look at what this looks like. What does daily look like? Okay, and daily here, it'll tell you that R has created some groups by year, month, and day. So there's 365 groups. This is almost like telling R, treat each date as separate, right? So treat January 1st separate than January 2nd. That's what's happening when you try to do group by in this way, okay? Now you, by itself, it doesn't have value, but you can use that with summarize. So maybe what you want to look at is how many flights were there on each day, and maybe you want to arrange it in some way, right? So one thing we can do is we can take those daily flights that we just created here, right? And we can then summarize that in this way and call it daily flights. So this is just a summary of all of the flights. Here we are just using the counts, right? And then we are counting for each date how many flights operated. So this is telling me that for the January 1st, 2013, there were 842 flights that operated, okay? And then January 2nd, 943, and so on and so forth. Now you might be interested in actually arranging this. So we can we can see that, in 2013, which day was the most popular, I guess, in terms of the most frequent flights, okay? And then we can take the, we can take the daily, flights, and we can say, and then arrange in descending order of n. N is already available to us here, right? So we're just arranging that, and we see that there were 1,014 flights on November 27th, right? And that was the most, I guess, day where flights were most frequently operated. Now, it's possible that once you have grouped something, you want to ungroup it and then summarize something, right? So you can ungroup very easily. You can take whatever you had done before, you can put ungroup on it, okay? And then notice when you look at the data set, it doesn't really tell you that there is any grouping going on. And if you summarize it, using a data set that is already ungrouped, then it's going to tell you that the average delay, let's say we were trying to again understand what was average delay, the average delay for all of the flights together, right, which is 336,776 flights, was 12.6 minutes, right? So that's pretty good, right? There are obviously outliers in our data. Now there is a function called dot by, or sort of an argument dot by, that you can use if you don't want to do what we were doing before. So this is sort of new, so you should just learn about it. We can also use the dot by argument to group within a single operation, okay, but it can work with multiple variables as well. So let's say if we want to use we still want to group by a single variable. So instead of doing group underscore by month, we can take flights and we can summarize. We can start summarizing it, and then later on we can say this is by month, okay? This is going to be pretty much the same as what we were doing before, just that the style or syntax is a little bit different, okay? Similarly, if you want to group by multiple variables, you can do that as well. So if we wanted to look at the counts of flights for unique origin and destination pairs, we can do that. Again, remember we had 224 unique pairs, and then we can look at multiple different summary stats for it. So here we not just output origin and destination, but we also look at average delay, which we are computing here in our summarize function. But also within the summarize function, we are also saying this is by origin and destination. That's why those two are reported. But we are getting average delay as well as the number of flights that were operating for each of those combinations. Okay, so with that, this wraps up the data transformation chapter. I'll see you in the next video.